Press the bell icon on the YouTube app and never miss another update.
Next, we deal with the different kinds of functions, namely one function, next onto function, next bijective function. It is especially related to 12th standard CBSE. Right. So first I will take one function. One function or injective function. One function means, listen, for example, f from capital A to B is a function. It is a function, not a relation, function. Okay. So that, for example, it is capital A, it is capital B, say X, Y, Z are the elements of capital A, and 1, 2, 3 are the elements of capital B, and X is mapped with 3, Y is mapped with 2, and Z is mapped with 1. Means what? Different elements are mapped with different elements of capital B. So therefore, here what happened? This is F under F. Here different elements of capital A are mapped. Okay, I will write the full form. Mapped with different elements of capital B. Different elements of capital A are mapped with different elements of capital B. What does it mean? For example, in capital A, A1, A2, these two are within bracket, A1 not equal to A2. They are mapped with different elements, means its image is f of A1 and its image is f of A2. So therefore, for all A1 comma A2 that is belongs to capital A, so and so that A1 not equal to A2, that implies f of A1 not equal to f of A2. From the definition itself, I wrote this sentence, means different elements, different images. So therefore different elements means pre-images. Already I said this is the pre-image set. This one is image set. Different pre-images in capital A are mapped. Rather than that, it is better to use the word will have different images. That's why the condition will started from inequality. Different. Understand? 1 minute here. So therefore I will write the definition. Let f from A to B be a function, be a function. So if different or distinct different elements of capital A are mapped with different elements of capital B, then F is called as 1 or injective function. Next, note. What is that note? For all A1 comma A2 that is belongs to capital A and A1 not equal to A2, that implies F of A1 not equal to F of A2. Remember, most important point, A1 here, I will write here, you come here, A1 note. So actually the definition started from the word different. So important note, A1 means elements are same, that implies F of A1 is equal to F of A2 doesn't gives the 1 function. It is not the definition of 1 function. But one exemption is there. If images are the same, means if F of A1 is equal to F of A2, that implies A1 is equal to A2, gives that F from A to B is an 1 or injective function. Remember, this part is very important, and this part is very important, and this part is very important. Okay, so therefore mostly in our problems, exercise problems, we are using this one. 90% we are using this definition or this definition. Once again, this is not definition for 1 function. Don't take A1 is equal to A2, and thus don't prove F of A1 is equal to F of A2 for 1 function. Understand? Next, I'm telling that if note another note, if F from A to B is not 1 function, then it is many to one function. Example, many to one. Capital A, capital B. This is suppose F, X, Y, Z, 1, 2. X is mapped with 2. Y is also mapped with 2. Z is mapped with 1. It is called many to one function. First, it is a function. Many to one. Many means more than one element is mapped with one element of B. So therefore, here x comma y that is belongs to capital A will have the same image. Means what? More than more than one pre-image, more than one pre-images having only one image in capital B. This is the simple definition of one function or injective function. Next, onto function or surjective function. Listen. Capital A. This is capital B. X, Y, 1, 2, 3. Here, X is mapped with 1 and Y is mapped with 1. Let us take Z. Z is mapped with 2 and let us take another point P. P is mapped with 3. So, it is called pre-image set. Pre-image set. It is called, this one is called image set. Okay, it is under F. Clearly, we see that the element of capital B. In the definition of the function, we are discussing through the first set. Remember, if possible, you can watch that previous episode about the functions. Functions 11th standard basic or board syllabus video. Watch it. After that, you watch it onto definition. Means that there will be some difference between the approaching between one function and onto function, not one function and onto function. In the definition of the function, we are approaching through capital A, but in the definition of onto function, we are going through capital B, just like that. Okay. So therefore, here one will have more than one pre-image in capital A. Here also 2 will have only one pre-image, 3 have one image. What I am telling that here every element of every element of B will have at least one. At least one means actually one is occurred as the image of more than one element in capital A, just like that. So that's why I use the word at least one. At least one. Every element of B will have at least one pre-image in the set capital A. Here f of x is f is equal x is mapped with 1 and y is mapped with 1. Next z is mapped with 2. Next p is mapped with 3. Okay. So therefore clearly we see that this is the first coordinate. Next these are the second coordinates. Here second coordinate means in the second coordinate one number is repeated. That kind of functions are said to be onto function. This kind of function f is called onto function. Understand? Here domain of f is equal to, of course, capital A, x, y, z, p. Next codomain is equal to, of course, capital B. Capital B is what? 1, 2, 3. Next, what about range? Range is equal to, already I said, this is the set of all images. Set of all images. How can we find the set of all images? Two methods are there. Namely, one occurred as the image of so and so element in capital A. Therefore 1, at least 1. Okay, 1 is also the image of Y. Next 2 is the image of Z. So 2. 3 is the image of so and so element. So 3. So this is called the image set. Unexpectedly it is equal to B. What I am telling that indirectly f of A that is equal to B, or in sets language we can say that f of A is improper subset of capital B. So therefore f of A is a subset or equal to, or f of A is subset or equal to B, we can say normally like that, or f of A is improper subset of capital B. Both are same. So therefore if f of A equal to B or f of A is a subset or equal to B, then f is called onto function. F is called onto function. So this is the right definition. Once again, let definition. Let f from capital A to B be a function. Actually, I said already in the previous basic classes, it can be written as f of x that is equal to 1. F of y means y is mapped with 1 under f. Next, z is mapped with 2 under f. It is the complete meaning. Next, comma, f of p that is equal to 3. What I am telling that f of x is equal to y. Complete meaning, actual meaning means that x is mapped or assigned with y, comma, under the function f. This is the complete meaning. So what I am telling that let f be a function if every means we can write another way. Already I wrote the definition. Every element of B will have at least one pre-image in capital A. So another way, in other words, we can write for all B belongs to, means we have to come through capital B. Already I said for onto function. For onto function, definition will started with B set. For function, the definition will started from capital A. Later I will write B belongs to capital B. There exists at least one A that is belongs to capital A, so that B is equal to f of A. We have to use this word. There exists at least one A, so that B is equal to f of A. Means this is B, this is A. F of A equal to B. In the same manner, in the same sense, in the same structure, we are writing this word like that. Understand? Means what? This is capital A, this is capital B. If B is there, definitely B will have at least one pre-image, so that for example it is A. So therefore for all B belongs to capital B, there exists at least one this A. Means either this or all, this one or both, or this one or three or all. So at least one small a that is belongs to capital B, so that f of A is equal to B or B equal to f of A. Then f is called onto function or or F is called surjective function. Okay, what I said, just I will recall the definition of the function. How we are writing for all A belongs to capital A, there exists unique small b belongs to capital B, so that B is equal to f of A. Then f from A to B is called a function, is called a function. Definition starting with for all A belongs to capital A, on to function for all B belongs to capital B. Unique, at least one. Okay, remaining same conditions, f of A equal to B, like that. So it is the definition of the function, it is the definition of the onto function. Later, if f is not onto function, then it is said to be into function. I will write one sentence. Therefore, or note, we can make a note. If f from A to B is not an onto function, then it is called into function. Into function means what? There does not exist at least one pre-image. Understand? Okay, let us take one example. Capital A, capital B, 1, 2, 3, X, Y. For example, I will take like that. Next, like that. Okay, enough. Next, we can take Z also, like that. Understand? So, therefore, 1 occurred as the image of 1 occurred the image of the 1 occurred image of X, that is belongs to capital A. Next, 2 is occurred as the image of 2 is the occurred image of Y, that is Y belongs to capital A. What about 3? 3 no. So 3 does not occurred as the image of any element of capital A. So no image, there is no image, it is a function, right? It is not one function, because two elements, different elements are mapped with only one element. Next, for 3 there is no image. For 3 no image means no pre-image. For 3 there is no pre. 3 is the image, actually it is in the image set. There is no pre-image in capital A. Therefore this kind of function, therefore f from A to B is not a function, is not an onto function. So whenever it is not an onto function, therefore f from A to B is an into function. Okay, this definition is over. Next, another simple definition: bijective function. Bisective. Bisective function. Bisective. Bisective means if f is one function and onto function, then f is called as bisective function or one correspondence. It is called bisective. So once again, one simple definition: bisective means if f is one function and onto function, then only it is said to be a bisective function. For example, listen. Capital A, capital B. This is F, X, Y, Z. 1, 2, 3. X is mapped with 3. Y is mapped with 1. Z is mapped with 2. So X, Y, Z, different elements are mapped with different elements in capital B. But I am telling that different elements of capital A are mapped with different elements of capital B. So therefore f is one function, and that to be 1. It is in capital B. It has at least one pre-image in capital A. Right. Second element. It has at least one pre-image in capital A. Next 3. It has at least one pre-image in capital A. Therefore, clearly every element of capital B will have means having at least one pre-image in capital A. Therefore f is onto function. So therefore f is one function and f is onto function. Therefore f is one and onto function. Therefore it follows that f is bisective function. Bisective function.